All right, let's move on to page 7. We'll call this part 2 of 8.2. So the first part, if you went to your assignment, you could, do those first parts, first 9 questions. The second part is some application questions that we're going to talk about now. All right. So a couple of terms that we need to understand. Angle of elevation. Okay, that's basically, if you look at this figure, like there's this kid here looking up to the top of this tower. So from his line of sight, which would be straight across, okay, the angle that's formed from there looking up is called the angle of elevation. So, that's from his eyes. So if something were on the ground, let's say, like to the top of a tree, like a string was attached to the ground to the top of a tree, from the ground up, that would be the angle of elevation. Okay? From the horizontal flat distance up to whatever it is you're looking at, that angle that's formed is called the angle of elevation. Okay? Now there's also an angle of depression, which is the same thing, kind of just reversed. So if you're up high looking down to something, from straight across going down is your angle of depression. Now, with angle of depression, if you make this line of sight and the ground parallel lines, this angle right here and this angle right here would be the same angle. Parallel lines, if you remember parallel lines cut by a transversal, the alternate interior angles would be the same. Okay, so these two angles would be the same. So what I'm going to do with these angle of depression questions is I'm just going to use this angle, knowing that it's this angle, because it'll give me the angle of depression, then I'll use it as this angle, then I have my angle in the right triangle that I need to use. Okay, so when we get to that, we'll talk about it. Back up to angle of elevation. So in these application questions, they're just going to tell us a scenario, and we're going to draw the figure and determine, what parts, what numbers go where, what angles are what, and then solve, just like we did in the previous examples in the other video. Okay, let's see what we got here. See if I can get this to zoom just right. And let's see here. Put it over just a little bit. Let's see if we can get the whole thing on there. Okay. Hopefully that works for you. Okay, so example 3. The angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. So if we have a boat, let's say, here's a boat, it's fancy, to the top of a lighthouse, so we're going to basically make a right triangle. Okay, so there's the top of the lighthouse. So the angle of elevation, so that means we're going from straight across up. So this would be your angle of elevation right here. So that says it's 5 degrees, so I'm going to fill that in. From the ground, or from the boat, so I guess that would be, the ground or ground level, up to the line of sight towards the top of the lighthouse, 5 degrees. If the top of the lighthouse is 161 feet above sea level, so that means this side would be 161 feet. How far is the boat from the lighthouse? Well, that would be your horizontal distance. So we're looking for this distance right there. Okay, so now we have our numbers. Let's set it up like the previous examples. So from this angle, we have the side opposite and we have the side adjacent. So opposite and adjacent is tangent. So we'll just set it up. Tangent of 5, because that's the angle, is the side opposite over the adjacent side. And now, like the previous examples, we solve cross multiply. So tangent of 5 times x will be x times the tangent of 5 equals 161 times 1. Now we divide by the tangent of 5. So that reduces. So x is going to equal 161 divided by the tangent of 5. So if we go to our calculator, and I'm going to go, let's see, 161 divided by, I'm going to use a parenthesis to enclose all of that that I'm dividing by, tangent of 5, and I make sure I'm degree mode. Enter. What is that? 1840.238421. So let's round that. The 8 will round to 3, so 1840.24. Feet, because that is a length. And that length. All right, you can also, if you have the answer key, you could follow along with what I'm doing on the answer key. I'm essentially just working them like I did on the answer key here on this paper. So, okay, next, the angle of elevation from the bottom of a slide to the top of the slide is 44 degrees. So, bottom of the slide, top of the slide. So, we're going to make a right triangle. The angle of elevation will be 44 degrees. The top of the slide sits 16 feet above the ground, so this side would be 16 feet. Find the length of the slide. Oh, we're looking for the hypotenuse. Assume that it's a straight slide. Okay. So from this angle, we find the angle, we determine the ratio. The ratio, we have the side opposite, and we have the hypotenuse. So that would be sine, opposite over hypotenuse. So we'll say sine of 44 is going to equal the side opposite over the hypotenuse. So now we cross multiply. Now we'll have x times the sine of 44 is going to equal 16 times 1. Divide by the sine of 44. So x is going to equal 16 divided by the sine of 44. You do that in your calculator, just like we did the previous one, 23.03 feet. Make sure you're getting the same number that I am. All right, a 10-foot ramp is used to unload furniture from a truck. So from the back of a truck, we're going to have a ramp that is 10 feet. Back of a truck, probably to the ground, probably making a right triangle like this. Let's see. If the back of the truck sits 3 feet above the ground, so that would be this. This would be like the back of the truck right here. Find the measure of the angle that the ramp makes with the ground. So that would be the angle that the ramp makes. So this is the ramp. This is the ground. And that's the height to the back of the truck. So the angle the ramp makes with the ground. So now we're solving for the angle. So we'll go to our trig function. From that angle, this is the side opposite, and that's the hypotenuse. So let's see. Opposite and hypotenuse, that is sine. So we'll go sine of the angle equals 3/10. And then from the previous questions, you remember to find the angle, we have to do the inverse. So the inverse of the ratio equals the angle. So on my calculator, I'm going to go, let's see, second sine, it was 3 divided by 10. 3 divided by 10, close that, so the inverse sine of 3/10 is going to give me the angle. The angle is 17.457. So we'll say 17.46. Degrees. Don't forget the degrees symbol. Okay? All right, that's angle of elevation. Now let's move on to some depression. Let's see here. A fire, let's review. Angle of depression is the angle going down from a certain spot down to something else. It's like an airplane in the sky going down to the runway, or, lifeguards sitting up here looking down to a swimmer. That angle of depression will be this angle, same angle down here, which is an angle of elevation from the other end of the figure or the scenario. Okay, we'll get to that. A fire is spotted from the top of a 125-foot tall fire tower. So here's your fire tower, 125 feet. A fire is spotted from the top of this. A fire is spotted down here. Ooh. Okay. If the angle of depression, so I'm going to draw my right triangle to the fire, along the ground, make my right triangle. If the, let's see, where are we? If the angle of depression to the fire, so that would be from my straight line of sight there down to there, that's my angle of depression, that's 19 degrees. So that also means this is 19 degrees, and that's the one I'm going to use. Okay, I want the one in the triangle. So the angle of depression is 19 degrees. How far is the fire from the base of the tower? So I want this side right here. Fire, base of the tower. Okay, so everybody understand how this angle goes? My angle of depression from this end, from the highest spot, the angle of depression is the same as the angle of elevation from the low end. Okay? So that's how we're going to use angle of depression. We're always going to use that other angle because that one is in the right triangle. Okay, so let's set it up. From this angle then, I have the side opposite and I have the side adjacent. So that would be tangent. So I'm going to set it up as tangent 19 equals the side opposite over adjacent. Then we cross multiply. Tangent of 19 times x, so that would be x times the tangent of 19 equals 125 times 1. Okay, divide by the tangent of 19. So that reduces, so x is going to equal 125 divided by the tangent of 19. So 125 divided by the tangent of 19. I think I'll 125 divided by parenthesis tangent 19. Close parenthesis, enter. 363, I don't know if you can see that, but your calculator, 363, 125 divided by the tangent of 19, 363.03. So we'll write it as 363.03 degrees. Oh, sorry, not degrees. What are we doing? Feet. Hopefully that was not blurry for the whole thing. All right, let's go. Next, an airplane flying at an altitude of 8,900 feet over water. Airplane, 8,900 feet above the ground. Airplane. The pilot spots a raft floating in the water. So here's my right triangle, spots the raft down to there. Angle of depression, so from the airplane here, the angle of depression is 28 degrees, so here would be 28 degrees, and we'll use that one. What's the horizontal distance from the airplane to the raft? So the horizontal distance, that's this right here. Okay? Not line of sight. So the horizontal distance, vertical distance, horizontal distance is here. So this will be the x. Okay, so this sets up just like the previous one, it looks like. We've got this side, we're missing this side, and we have this angle. So that was tangent, opposite and adjacent. So tangent 28 over 1 is the same as 8,900 over x. Cross multiply, same as the last one. Same exact situation. Cross multiply, divide by tangent of 28. So x is going to equal 8,900. 8,900 divided by parenthesis tangent 28. 16,738.465, so say 0.47. So we'll say 738.47 feet. $16,000. All right, let's see. Max. Max is sitting in the stands at the baseball stadium. He catches a foul ball and decides to throw it back to a player standing on first base. So here's Max in the stands, catches the ball. He's going to throw it to somebody at first base. Let's make our right triangle with Max here. If the horizontal distance from Max to the player, from Max, horizontal distance, that's this, remember, is 61 feet. And the ball travels 76 feet, so that would have to be this. That's his throwing. Threw it down there. What is the angle of depression from Max to the player? Well, the angle of depression would be this angle up here, but we're going to find this angle because it's the same angle, and that one's in our triangle. So how do we find the angle? Let's see. I have the side adjacent, and I have the hypotenuse. So that's cosine. So I'll say cosine of the angle equals the side adjacent over the hypotenuse. And to find the angle, we use the inverse. So we're going to go inverse cosine of the fraction 61 divided by 76 equals the angle. So on my calculator, let's see. On my calculator, let's go second cosine. So cosine the negative 1. And 61 divided by 76. In parentheses, enter, and my calculator in degree mode gives me 36.62. So that would be 36.62 degrees. All right, those are your application problems. So on your assignment, you probably already started this one because I broke this up into two sections, but you're solving for sides and angles, okay? And then the applications are just like the examples, okay? So you just have to set it up, and that's it. All right, so after this, there'll be a review, quiz, and we'll move on. Happy Unit 8.